derivative of an inverse function. Our objective is to find the derivative of an inverse function. Remember that inverse functions means the x and y switch. If f and g are inverse functions, then f of g of x will equal g of f of x, which equals x. Now today we're talking about the derivative of an inverse function. So let's take the derivative of f of g of x, which equals x. Let's see what that looks like. The derivative with respect to x of f of g of x, which means we're taking the derivative with respect to x also of x, because those will be equivalent to each other when f and g are inverse functions. That leads us to, using the chain rule on the left side, f prime of g of x times g prime of x. On the right side, the derivative of x is 1. Solving for the derivative of g of x, because we want the derivative of the inverse function, we get that g prime of x equals 1 over f prime of g of x, because we've divided by what's multiplied to g prime of x. So it shows that if g is the inverse of f, its derivative is the reciprocal of the derivative of f with g of x plugged in. To be a little bit more clear, let's explore an actual function and its derivative and its inverse. Let f of x equal x cubed. Then f of 2 equals 2 cubed, which is 8. So it is true that on the graph of f, there is the point 2, 8. The derivative, f prime of x, if f is x cubed, will be 3x squared, and the derivative of f at 2 will be 3 times 2 squared, or 3 times 4, which is 12. Now let's let g equal the inverse of f to the negative 1. Remember, that's notation. That means the inverse of the function f. So up here we can give ourselves a reminder that f and g are inverses. Another way to show g is f to the negative 1. So g is the inverse of f. What does g of x equal? Well, remember that inverse is switching x and y. So if f is x cubed, which another way to think about that is y equals x cubed, on the g graph, that would be x equals y cubed, because we switch the x and the y. Now to see what g of x equals, we solve for y. So y equals the cubed root of x. So g of x equals the cubed root of x. So remember that on the graph of f was the point 2, 8. Then it must be true that on the graph of g will be the point 8, 2. Well, let's see. What is g of 2? G of 8 equal to? That requires plugging 8 into cubed root of x. So cubed root of 8, that equals 2. So it is true that on the graph of g is 8, 2. Let's explore its derivative, g prime of x. Well, if g of x is cubed root of x, another way to think of that is x to the 1/3. And when we take the derivative, we can use the power rule, 1/3 x to the negative 2/3, or the other way to write it, 1 over 3 times cubed root of x squared. Let's go ahead and plug in the x value from the g function and see what g prime of 8 is equal to. That's 1 over 3 times the cubed root of 8 squared. Now when we're doing the squared or the cubed root, doesn't matter which one we do first, so I'm going to pick the way that's going to make it simpler first. Cubed root of 8 is 2. 2 squared is 4. So that gives us 1 over 3 times 4, or 1 over 12. Well, isn't that interesting? What do we notice? This value, the derivative of g, is the reciprocal of this value, the derivative of f. Notice we didn't plug in the same x value. This was the derivative of f at the x value 2. This is the derivative of g at the x value 8. But they are the x values that go with the function at their respective points where the x and the y switch places. So we remember that the derivatives of the inverses are ultimately reciprocals of each other. Let's look at this yet another way. On the graph of y equals f of x, the points are x comma y. On the graph of x equals g of y, notice that's the inverse because x and y is switched, are the points y comma x. The x and y are switched. So it should make sense that if f prime of x is dy over dx, then the derivative of the inverse g prime of y is dx over dy. Simply the reciprocal because we switch the x and the y, so dy dx is now dx dy. So an important note, if y equals f of x and x equals g of y are inverse functions, then the derivative with respect to x of g of y, where y is a value of a, is the same as saying g prime of a, which is 1 over f prime of g of a. This is what we noticed in the beginning when we did the derivative of that composite function. Let's apply this to some examples and see how it can work for us. If g equals the inverse of f of 4 equals 3, and f prime of 4 equals 9, find g prime of 3. So we remember this important fact about the derivatives of inverse. G prime of 3 equals 1 over f prime of g of 3. But what is g of 3? They did not give me that value. But remember, if on the f graph is the point 4, 3, then on its inverse, g is the point 3, 4. So g of 3 is actually known. It's 4. So this is the same as saying 1 over f prime of 4. F prime of 4 is a value they gave us, so we can replace it, and we get 1 over 9, just like that. Two, the function f of x equals x to the 5th plus x has an inverse function g. Find g prime of 2. So I start with remembering that g prime of 2 means 1 over f prime of g of 2. And that's because the inverse function of f is g. Now what is g of 2? I don't have any values given to me here. On the graph of g, there will be the point 2, something. The x value for g is 2. I don't know what the y value is. They did not give me any values for f, but I do know that the x and y switch. So on the f graph, there is a point something, 2. That means that 2 is the y value for f of x. So I can take that function that they gave me and use it to find the x value. So x to the 5th plus x equals the y value 2. Noticing that 1 plus 1 will equal 2. So 1 to the 5th plus 1 equals 2. By inspection, x must equal 1. So now I know that these values are 1, and g of 2 is 1. So what I'm really looking for is 1 over f prime of 1. Now I can deal with the derivative of f of x. Let's go ahead and do that. F prime of x equals 5x to the 4th plus 1, using our power rule for that function. And so f prime of 1 is 5 times 1 to the 4th plus 1, or 5 plus 1, which is 6. Now I can substitute that in there, and I get 1/6. Thanks for watching.